Hi, let's look at this simultaneous equation that we are going to solve using the elimination method. Okay, so this is a very common method that is used to solve simultaneous equations. The other method is the substitution method, which I will explain in other videos. All right, so look out for those videos in the .r YouTube channel. Now, for elimination, what we want is to get rid of one of the variables. So here we have two variables a and b, and we want to get rid of one of the variables. Now, if the coefficients of both the variables in the different equations are the same, then it is easy. Okay, so let's rewrite the question here. So I have 3a plus 2b equals to 16 and 4a plus 6b equals to 28. Now, as you can see, for a, both the coefficients are different, 3 and 4. And for b, also both the coefficients are different, 2 and 6. Okay, so since the coefficients are different, we then need to do some manipulation, okay, to make the coefficients the same. Alright, so the first step is we're going to label the equation. So this is equation 1, this is equation 2. Now, what can I do to make both the equations have a common coefficient for one of the variables, either a or b? So here, for example, if I look at a, you can see that if I can multiply equation 1 by 4 and equation 2 by 3, and then both of them will have 12, correct? But for that I need to multiply both the equations. But if I look at b, for equation 2 it is already at 6, okay? And if I just take equation 1 alone and I multiply by 3, then this will also become 6. Okay, so that is what I'm going to do over here. I'm going to take equation 1 multiplied by 3. Okay, and that will give me, so when I say equation 1 multiplied by 3, all of the terms in the equation must multiply by 3. Okay, so I will get 9a plus 6b equals to 48. And I'm going to call this equation 3. Okay, so now you can see that for equation 2 and equation 3, they both have the same coefficient for b. Okay, so 6b, positive 6b, if I subtract positive 6b, then the answer would be 0b or 0. So the b is eliminated, correct? So that is what I'm going to do. I'm going to take equation 2, subtract equation 3. Okay, so what I have left would be 4a minus 9a is minus 5a. b and 6b, when they subtract, you'll get 0 as what we just saw. And 28 minus 48, I get minus 20. So a is equals to 4. Okay, and once I solve for a, I can take a and put into any of the equations here and solve for b. Alright, so I'm going to take it and put it into equation 1. So I have 3a plus 2b equals to 16. 3 into 4 plus 2b equals to 16. So 12 plus 2b equals to 16. From there I get 2b is equals to 16 minus 12, which will be 4. So b is equals to 2. Alright, so the final answer is a is equals to 4 and b is equals to 2 for this simultaneous equations question. So once again, I hope this video has helped you with understanding how to approach such questions using the elimination method. Thank you very much for watching and look forward to more such videos from the .r YouTube channel. Thank you. Bye.